Kia ora, Year 12 and 13. This is a scholarship calculus question from the 2008 paper. And if you're at Wellington College, this is the one that Mr. Clark did this morning in the Thursday session. Because there's no Friday session tomorrow morning because of midterm break, I thought I'd do a YouTube of it. So this question is really, really wordy, and it doesn't look like there's much maths in here, but there is. So looking through it, the first thing we have to do is figure out how to write the differential equation. So we've got a rumour about a teacher that started in a school of size P students, and it's going to spread at a rate that is proportional to the product of the number of students who know the rumour and the number of those who don't. And we have to figure out an expression for the number of students, N, who know the rumour after T days. So let's start by first of all setting up the DE. The second part of the question is going to make us solve the differential equation and get what we call a particular solution. So I think one of the tricky things to remember here is that we're going to have an N and we're going to have a P. So the rate of change that we're working with is dN by dt. Okay, so that's the rate at which the number of students who know the rumour changes. So dN by dt is proportional, K, to the product of the number of students who know the rumour, N, and those who don't. So those who don't will be the total school population minus those who do. But just remember that the variable here is not P. The variable is N. P is just a constant. Okay, so remember that, and we're going to call that equation star because we're going to come back to that quite far through the problem. So we're going to apply the only thing we can do in level 3 or scholarship, and that is the method of separating the variables. We're going to get everything that's got n's in it over to the side with dn and leave everything else. So if you're watching this, that step should feel reasonably straightforward. So this is the left-hand side, and then we're going to have k times dt here. Right, now if that doesn't feel comfortable, it's time to go and grab delta and go over the basic stuff on applied differential equations. So that's what we want to do. Now, the problem we've got is that this is quite tricky to anti-differentiate. If you don't like looking at the n's and the p's, think about if we had x over, I don't know, 13 minus x. So if you had to integrate that, that would be awful as well. We're going to use partial fractions to do that, and as Mr. Clark said this morning, if you don't know partial fractions, that's not surprising because they're not taught at level 3 anymore, but there are 3 separate YouTube videos that I've done that go through those. If you're doing Cambridge A level, you'll be pretty comfortable with the partial fractions method that I'm about to do, so just skip through this part of the video. So what we want to do is we're going to take this expression and we're going to split it up into 2 fractions. So we're going to try and write this as something over n plus something over p minus n. And we don't know what these numbers are in the top line, so we're going to call them a and b. Right, now the method I'm about to show you, I'm going to go a little bit quickly through. Basically, we're going to cross multiply here to get a common denominator. So we'll get 1 is equal to a times p minus n plus b, just bn. And we're looking for the a and b that will make that true for all values of n. The way that we can go further, or one way that we can go further, is to say, well, let's see what happens if n is equal to 0. That gives us 1 is equal to a times p minus 0 plus b times 0. That gives me 1 is equal to AP, and 1 over P is equal to A. Right, if this is your very first ever partial fractions exercise, it's quite a tricky one because we're working with P here. We're going to do the same thing now to figure out B. So we do that by saying, let's let N equal P. That gives me 1 is equal to A times P minus P plus BP, giving me 1 equals BP. So B is also equal to 1 over P. that means that we can now go ahead and break up this expression into two fractions. Right, remember that p is a constant. We're now ready to put that back into our differential equation and start integrating. So we'll rewrite it as follows. So all of that is integrated with respect to t. We can take out a common factor there, which is a constant of 1 over p. So we've got 1 over p times 1 over n minus 1 over p minus n dt. And we know that that is equal to k dt, putting back in the right-hand side of the differential equation. Oops, don't know what happened there. Okay, so the integration is now reasonably straightforward. I've got to stop writing that equal sign. There we are. 1 over p times the natural log of n minus, oops, what happened there? The natural log of p minus n. Now I've made a mistake there. I should have a plus back up here. Okay, so there are pluses in there, not minuses. But the reason I need to have this minus sign here is when I go ahead and differentiate this, it's going to generate a negative in there. So I need to change that to a minus sign. Right, hopefully that's as clear as mud. And then over here, we get kt plus the constant of integration. Remember that plus c is just an arbitrary constant. We'll deal with it later. So the next step is to sort out this log, and we get n over p minus n is equal to p timesing through by p, pkt plus pc, which we're going to write as pkt plus just c dash. This is still just an arbitrary constant. Now let's do e to the power of both sides. It gives me n over p minus n is equal to e to the power of pkt plus, oops, c dash. Okay, so we get to here, and then we're going to work with this plus c. So we can rewrite this as n over p minus n is equal to e to the pkt times e to the c dash. And we can write that as another arbitrary constant, a. Okay, and you will have gone through this in class when you're doing level 3, that we really don't care if we call this c or c dash or e to the power of c dash. So the notation we usually adopt is a capital A here. Right, so we're just about there on the first part of the problem. We've got to get an expression for n. So we can multiply through, oops, not p, n is equal to p minus n times a e to the pkt. So n is equal to pa minus, right, what I'm doing here is I'm trying to get everything that's got n in it over to one side of the equation. So we're going to have n plus n a to the e pkt is equal to pa e to the pkt. Taking out the common factor gives me this. And finally, we get an expression n as follows. So there we go. So that's the general solution for the number of people in the school who know the rumour at any one time. Now there are two things that we don't know in here, so we can't use it to solve the problem just yet because we don't know A and we don't know K. In the second part of the problem, we're given a specific situation, and we're going to use it to work out both of these two things. But because this is 10 minutes long already, I'm going to upload this half and then come back to the second half shortly. Thanks for watching.